Hello everyone, I'm Sai. In this video, I want to show you how to perform gradient in Pytorch. Pytorch basically have a gradient engine that performs the gradients because it is essential in machine learning, right? And it's Pytorch is not only the one who provides the gradient operations. There are also other libraries, for instance, SymPy and SciPy. And the PyTorch basically uses a computational graph technique and the backwards chain rule, so where it computes the gradient. So I'm not going to go in depth at how the mechanism of this gradient works, and I'm only going to show you like the operations that how we use. And for the better videos, watch other source, and if possible, I will try to provide a link in the description without wasting any time. So the topics that I will be covering is that how you will be performing a gradient. There are two ways to operate a gradient. So one is using Auto-Grad and one is using backward. And what is the advantage of using Auto-Grad? I will explain you. And I will also show you that you can how you can use for the multiple values and multiple independent variables and single valued on a single variable and choose as such. And this is the we have prepared, and I will walk you as a side by side. Where one part I will be explaining, and another part you can just look at the code or look at whatever it is written. Anyway, firstly, I have what I'm going to do is that I'm going to try to explain. Just forget it. I will try to create now. I'm going to create a torch where I'm going to create a tensor. I'm passing a single value, okay? I'm passing a single value, and I have this y is equals to, let's say, x squared, and I want to perform this x and y value. So at x is equals to 1, y is 1, and okay, what happens if x is equals to 2? I'm getting a 4. Okay, now our function is working. Now, how do I perform the gradient on this? So when I try to perform a gradient, two ways to do it. You have to say required grad is equals to true. And so when you try to do it, it's going to throw you an error because that you need in order to perform a gradient, that whatever the input value that you're providing. So if I try to do this, it will work. Or you can either do this, or you can just sync types in float and torch dot float 16, let's say, and that will also give you the same results. So you can just evade by just passing the data types. Okay, that is one thing. Now, how do I basically compute the gradient of it? And to do that, um, all you have to do is simply say y backward and try to run it. Okay, I'm saying dy is equals to y dot backward. So when I try to do this, okay, now when I try to see nothing, because the gradient is not stored in this, but rather it is stored in the value of x. So how do I see it is by performing x.grad, where it stores the value of x here. Now that is that is very simple and that is very nice. Okay, now what happens is what if I have a value and which is x cube and I perform z. Now I have x cube like 2, 4, and 8 based on these operations that you could see here. Now I would eliminate this. Now we understand that we don't need to assign the value to it. Um, Now I'll say y dot backward, y dot backward. That's fine. Now I should supposed to get a 4, which I'm getting. That is true. So, but what if I'll try to create one more z dot backward, because I also want to find the derivative of z with respect to x. Okay, since I cannot store these values into a different variables, because the x is only accumulating those values, right? So I say z dot backward, and when I try to say here, when you're differentiating with respect to z, you're getting 3 multiplied by 2 squared, which is 12, and instead of getting 12, you're going to get 16. The reason is that the x grad basically accumulates. So let's suppose that you have f1, f2, and fn functions, and when you're trying to perform the gradient to it, x grad is basically it's going to simply add up all these accumulated values. So it's not going to give you an accurate results. To avoid this, we have two ways of dealing with it. One is you either zero it or none it. Now, how do I do it? I'm just simply going to run this again. Here, I'm going to say y backward, and I can say print x dot rat, and what I can do is that one is I can assign this to equals to none. Either I can do this or I can do this one. Either way, they are going to produce me. This method will give me 0, this will produce me 0. And the other one will produce, it's going to produce me none. Like it's not going to produce any output because it's setting its value to none. So that's one way to do it. And afterwards, I'm going to perform a backward. And when I try to print it, and right, grad is equals to none. So where I'm clearing, I need to clear this x dot grad dot zeros. So you can see that you're eliminating the, and there is other way of doing the autograd, and I think that is sort of efficient in comparison to this. I'll show you how to perform. Now this is one of the things. Now you're going to use torch autograd grad, and I have already imported my autograd grad. Now I'm going to use the same function here. Now what I'm going to say is that dz, and I'm going to perform grad, and I have this output function, which is a z, right? And um, input, since I have a single variable, I could just say either this, or I can simply say this one. Okay, you can see along the side note that how it's performing. You can see that your value is 12, like you're calculating dz value, and also you can say this equals to y. This value is this, and this value is this. Okay, now it is good. But what about the accumulations? We want to see if this method is accumulating the gradient, and we see that it is not, because it is being stored into this variables dz and dy, and it is eliminating the accumulation into this leaf nodes. Now this is that. This is that. So now you can perform either one of the two ways. You can use either backward method or you can use this method. And here I will explain you like why I'm using create graph. Now I have this function, right? I have this function. Why not just use it here instead of running multiple times? I have this one function here. And what happens if I want to calculate a d to z, which is a second derivative, right? And I'm going to give an input x. And when I try to perform it, I'm getting error. Okay, I'm getting error is because I wanted to, perform a higher order derivative, right? And in order to do that, I cannot just simply pass a variable and do it. I need to create a graph. So that would retain that property to do the further gradients for the higher orders. In order to do that, I can just create graph and I can set it to true. And when I try to do it, you could see that I'm performing for the z value, right? And if I try to see z value and dz value and d2z value, and you could see that the z value that I first provided was 8. Yeah, it is 8 because 2 to the power 3, 2 to the power 3 is 8, 2 to the 4 is 8. And this one is 12. So you have a 3 multiplied by 4, which is a 12. And it's a 3 multiplied by 2 multiplied by 2, 4, 8, 12 again. So you are getting this, what do we say? The higher order derivatives in this. So this is how you calculate higher order derivatives for a single variable. Now, let's suppose that you have a function, just this is the function that you have, and you have a multiple variables. And I'm going to remove this one. And I'm going to simply copy this. Oh, wait, I will just do one thing. I'm going to say 1, 2, 3, 4, and 5. Okay. And I'm going to copy this. I will copy this and okay, I say that this is equals to z square plus, sorry, x square plus y square. And when I try to run it, I'm getting like 2, 8, 18, 32, and 50. Okay. Now I wanted to perform for the gradient for the multiple values. Like I have the multiple values. How do I do it? And this is associated with the two functions. For now, let's say that we have only one function and with the multiple values. And I will show you in a two ways to do. One is that you could simply say backward and get an error because you have a different shape and it is expecting a scalar value. You could see that grad implicitly created for the scalar only is for the scalar output. To evade this, we have to say um, here, yeah, here you could see that the grad outputs in this here. What you're trying to do is that you have to define the shape. Like what is the shape of this output? Let's say some X shape, since I'm using X, so torch dot one slide, and I'm passing the X here. So I'm simply going to pass Yes, sure. Now, when I do this, and I will see the accumulation because I'm using this backward method. You can see that 2, 4, 6, 8, 10. So when I'm performing the gradient, it is a derivative like 2 multiplied by x, and it is working. It is working for the multiple values. So what I have to do is that I have to pass the input shape in this the gradient here, and I will get the same value. Now, I can do this similarly. I can do this into uh, the method as well. In here, what I supposed to do is that I have to pass a function, and here in inputs, I have to pass the value x, and I have to pass the grad outputs. The grad outputs, what is the grad outputs? It's X shape. It is stored in a DZ, the gradient is stored in a DZ, and you're getting the results. And this is perfectly working for the multiple values. And what happens if your function is associated with multiple values is X square. And to do that, so this shape and this shape needs to be equal. If you try to change anything, you're going to not going to get output. Now, this shape is same and the y shape is same. So either I can pass x or y since they both are same. Uh, what I have to do here is that instead of passing a single x value, I will be passing a list. A list where I will say this is the x and y value where I want to compute the gradients of it. And sorry, when I try to run it, and when I see, it's giving me the gradients in terms of a tuple. So one is a partial derivative of z with respect to x, and a derivative of z with respect to y. So I can access, if I want to access the first one, I have this one, and if I can access the second one, I have this one. So that is well and nice. And that is how you perform gradient for higher order derivatives. So we have covered how to calculate the gradient for the single variable and a single value. And we have covered how to calculate for the multiple values and how to use two ways for computing gradient. One is storing within the parameters the gradient accumulations. So we are accumulating it, and using AutoGrad, we are basically avoiding that kind of accumulations and storing that gradient values into the variables. And how to perform higher order derivatives, what method I actually forgot. Yeah, create graphs. So create graph, a short note, create graph, what it does is that it's going to create a computation graphs. And because of this, it's going to retain the property for the computations. Anyway, if you like the video, please do subscribe, and thank you for watching.